Students, we of light, and yesterday I discussed the concept of refraction of light with you. Okay, yesterday I discussed refraction of light with you. Okay, how can we define refraction when the light will move from one medium to another medium? So basically, light will not move in a straight line, it will bend. It is bending because of the change in speed of light. When the light is traveling in air, so its speed is greatest. But when the light will enter in denser medium, its speed will decrease. So this decrease in speed will bend the light towards the normal. This phenomena is defined as refraction of light. I am repeating, beta. This phenomena is defined refraction of light. Okay, so whenever light will move from air to denser medium, it will bend towards the normal. When the light will move from denser to air, it will bend away from the normal. Okay, this ray which is incident on denser medium, like you can see the denser medium is glass block here, so this ray is called incident ray. This ray is called refracted ray because it is reflected in the denser medium. And this ray which is coming out in air again, it is called emergent ray. Angle of incidence and angle of emergent are always same. Similarly, angle of refraction and this angle in denser medium, they are same. Alright students. And remember beta, when the light will enter from air to denser medium, it will bend towards the normal. And when the light will move from denser to air, it will bend away from the normal. Yesterday, I discussed the two formulas with you. The first formula is Snell law. What is Snell law? Snell law is equals to N is equals to sine I over sine R. Sine I is basically the angle of incidence, alright, and sine R is angle of refraction. Inaya, where is Suresh today? All right, a student, that is defined as angle of refraction, refractive index. Refractive index, oh, 1 minute. Refractive index will tell the property of a material that how denser the medium is. All right, students. Acha, the second formula which I discussed with you is speed of light in denser medium divided by speed of light in air divided by speed of light in denser medium is equal to refractive index. All right. So as the light will move into the denser medium, it will slow down. So that's why its speed will change. Okay, Naya. All right. So today, students, we have to discuss the law of refraction. Yesterday, we have solved some past paper questions, numericals. So today, I want to discuss this law of refraction. Then how can we define refraction, beta? But I want to show you video related to laws of refraction. So you can see I have already opened this video for you. Okay. So you can see this is a power supply, ray box, rectangular glass slab, pencil, protector, meter rule and taper. These instruments we are required to perform the experiment of refraction. This experiment is important for ATP and for theory beta. So first of all, we will keep the glass block on the white paper and we will draw a boundary around it. You can see we are drawing the boundary around it and we will mark normal at the center of this line. Okay, you can see how we will keep the protector. We will keep the protector straight and mark at 90-degree angle. All right. So we will join these two lines. So this line is a normal which is perpendicular to the surface. Okay. This line is normal. All right, students. Now what we will do, we will keep the ray. Okay, 1 minute. We will keep the glass block and we will have set the ray box. So you can see beta, this is the ray box. The light is emitted from the ray box. All right, this is the incident ray. We will mark two crosses here. All right. We will mark two crosses here. This is the ray box. All right. It is emitting the light. We have marked the two cross. All right. And you can see the reflected ray appear to act here. So we will mark two cross here as well. Okay, so what we will do, beta, we will remove this ray box. We will remove this glass block as well, and we will join these rays. We will join these rays in the last. So you can see actually the light should travel in a straight line like this, but it appears to be bended. So what we will do, we will join these two lines. So this ray which is appearing at a center is called refracted ray. All right. So what we will do in this experiment, we will set angle of incidence by ourselves. Angle of incidence is the independent variable here. We can set at 30 degree, 45 degree, 60 degree, and we will record different angle of refraction. First, we will draw normal here. All right, and we will draw angle of refraction at this point. Okay, so we will construct one table in which we will create different columns. Okay, 5 columns. All right, these things which I am telling you, beta, these types of question can be asked in ATP. All right, so first we will write angle I, which we are setting by ourselves like 30 degree, 45 degree, 60, whatever. Okay, then we will record angle R at different position. Okay, then I will calculate sine I, sine R, and in the last we will calculate the refractive index of this glass block. Okay, so basically this experiment is verifying the law of refraction, which is telling that the angle of refraction will be different when the light will enter in this denser medium. All right, students. Okay, so I will show you this experiment. I didn't show you the complete video. Instead of showing, I have explained you. All right, you can see we have created this table here. Let me zoom this picture so you can clearly see this. All right, these are the 5 columns. These are the column headings. देखिए बेटा, if this question will be asked in ATP, if they will ask you to draw the tables to verify the law of refraction, so just you have to draw the table and write the column headings. You don't need to write these values because we are not performing the experiment. We are attempting ATP paper. So just you have to write down the column heading like angle I, angle R, sine I, sine R. Then refractive index N is equals to sine I over sine R. So just for drawing this table with column heading, we will get 2 marks. Okay. Now you can see they have constructed the graph as well. On y-axis, we are taking sine I. On x-axis, we are taking sine R, and we are getting the straight line. So straight line is showing the direct relation between sine I or sine R. They are directly proportional because if we will increase the angle I, so angle R will also increase. All right, you can see here if angle I is 20 degree, angle R is 13. Angle I is 30, so angle R is 20. So it means if angle I is increasing, so angle R will also increase. It is showing a direct relation. Okay. And the gradient of this line is used to determine the refractive index. Gradient means gradient is equals to y upon x. So on y-axis, we are taking sine I. On x-axis, we are taking sine R. All right, so its gradient will give us the refractive index value. All right, students, is it clear to you? I have added few more past paper questions. So we can solve these questions in today's class. Look at this question, students. Question number 23. Have we solved this question yesterday? Because I don't remember exactly. Can anybody tell me? Have we solved this question yesterday? Okay. No? All right. Question number 23. In question number 23, they are saying a ray of light meet the face of a glass block at an angle of 30 degree as shown. So you can see beta, 30 degree is not angle of incidence. It is not angle of incidence because angle of incidence is the angle between incident ray and normal. So this is the angle of incidence. How we will find this angle? 90 minus 30, we will get 60 degree. So 60 degree is basically angle of incidence and this R is angle of refraction. Okay, Naya. So now they are asking to calculate the refractive index R and the refractive index value is given 1.5. So now students, we will use the formula N is equals to sine I over sine R. All right. So n is 1.5. Sine I is 60 degree. Now we have to calculate sine R. So we will move the sine R on the left side, 1.5 on the right side. So sine R is equals to sine 60 divided by 1.5. So R is equals to sine inverse. We will move this sign on the right side. Sine 60 divided by 1.5. So students, I want answer from everyone. Nafia, what answer you are getting? Ahmed, please tell me your responses. Well done, Ayan, Hafsa, Inaya. Most of the students are getting 35 degree. C is the correct answer. All right. Everyone is getting this answer, students. All right. Okay, beta. Note down this calculation so we are able to solve some more past paper questions. All right. Acha, most of the students yesterday didn't join the next meeting. In the next meeting, I told you the concept that what happened when the light ray will move from denser to air and how can we calculate the angle. So I'm repeating again, beta. You can see in this diagram is incident in the denser medium. Okay, you can see here, beta. Light is incident in denser medium. All right. So when the light will move from denser to air, it will bend away from the normal like this. Okay. So this angle is the angle this ray will make with the normal. This angle is 30 degree. All right. Which is in denser medium. देखिए बेटा, it appears like this that the light ray is incident in denser medium, so it is incident ray and it is refracted ray. But yesterday I told you this thing that if we will solve this type of question where we have to find this angle which is in air, so we will always take this angle I. Angle of incidence, I am writing here, angle of incidence is always in air. Angle of refraction is always in denser medium. All right. Angle of refraction is always in denser medium. So we have to consider these points when we are solving the numerical. So in this question, we have to calculate this angle. So basically, we have to calculate angle I. So now I will use the formula n is equals to sine I over sine R. So refractive index is given, that is 1.8. Sine I we have to find. R is basically 30 degree. So this term is dividing here. On the other side, it will be multiplied. So sine I is equals to 1.8 multiplied by sine 30. So I is equals to sine inverse 1.8 multiplied by sine 30. Now students, solve this and tell me what answer you are getting. What is the value of angle I? Okay, Hafsa is saying D. Students, remember this thing. Although this ray is incident ray, this must be angle of incidence and this must be angle of refraction. But when we are solving the numerical, so remember beta, angle I is always taken in air and angle R is always taken in denser medium. Okay, Ayan and Hafsa are saying D is the right answer. It means 64 degree is the correct answer. Understood, students? All right. So I hope you all have done. Now I'm going to clear the screen and I have added few more past paper questions which we can solve in today's class. Okay. Look at this question, question number 42. In this question, they are saying that diagram shows a ray of light incident on the surface of glass block. 1 minute, students. All right. So you can see, beta, this is the incident ray and this ray is partially reflecting and it is refracting as well. All right, it is refracting as well. So this ray is basically incident ray. This ray is refracted ray and this ray is showing reflection. Alright, this ray is showing reflection. Now they are saying the ray of light is partially reflected back into the air and partially refracted into the glass block. Which row correctly identify the angle of reflection and angle of refraction? So well done, students. You can see this is angle of reflection because it is reflecting. So and 1 is angle of reflection and 4 is angle of refraction. So B is the correct answer. All right, everyone. B is the correct answer. Okay. Done. All right. Now students, look at the next question. Question number 57. In question number 57, they are saying a ray of light is passed through air, glass and water. So there are two denser medium, basically glass and water. At which point does the light speed decreases? All right, so now you can see the light is, at point W is in air. All right, it is entering into the glass block. All right, then it is moving in air again as well. Then it is moving in the glass block. So which one is the right answer, students? Okay, Zen is saying A, Hafsa and Inaya are saying B. What about the students? Students, I'm waiting for your answer. Aiza, Khatija, Nafia. देखिए बेटा, in this question, X is the point which is in air. Although W is also the point which is in air, but the light is entering in the denser medium after passing the point W. So it means the light speed will decrease. But when the light will come at point X, so it is in air, so its speed will increase. But as the light will reach the point Y, so point Y is basically a door to enter in the denser medium. So it means when the light will enter from this point, so again the speed will decrease because water is a denser medium. So W and Y are these 2 points in which the light speed will decrease because they are entering in denser medium. So that's why beta B is the correct answer. All right, students, B is the correct answer because you can see at point X, the light is traveling in this direction. In this direction, so this is air. So obviously the light speed will be fastest in air. Okay. So W and Y are these 2 points in which the light is entering in denser medium, so its speed will decrease. Okay. Now you can see the next question, question number 60. In question number 60, a ray of light passes from air to glass. It means the light is moving from air to denser medium. Now they are asking what are the angle of incidence and angle of refraction. So it's a very easy question, students. You can see angle of incidence with is basically the angle between incident ray and normal. This is angle of incidence and this is angle of refraction. So 90 minus 50, we will get 40 degree, which is angle of incidence, and 25 degree is angle of refraction. So A is the correct answer. Understood? Is it clear to you? Assalamu alaikum, Abdul Rafi. Question number 63. In question number 63, they are saying the diagram shows a ray of light passing from air into a transparent substance. So now you can see here, the light is moving from air to denser medium. Angle of incidence is 40 degree. Angle of refraction is 30 degree. What is the refractive index? So now students use the formula of refractive index. N is equals to sine I over sine R. And tell me what answer you are getting. Okay. Ishal, what answer you are getting? Hurry up, tell me. Are you here in class, Ishal? Zen? Okay. Well done, Abdul Rafi. All right. So B is the correct answer. We are getting 1.29. Okay. So these questions are very easy. Okay. Uh, Two questions are remaining. Then we will start the next topic, that is total internal. Okay. Now, question number 67. In question number 67, they are saying the diagram shows a ray of light passing from air into diamond. What two angles are given, which is 60 and 78 degree. What is the refractive index of the diamond? So, student, these two angles are correct angles. First of all, tell me, these two angles are correct. First, we will draw the normal at this point. Oh, this is the normal which is passing through this point. This is angle of incidence and this is angle of refraction. So 90 minus 60, angle of incidence is 30 degree exactly, and 90 minus 78, angle of refraction is 12 degree. All right. So refractive index is equals to sine I over sine R. So I is basically 30 degree and R is basically 12 degree. So after dividing, what we are getting, student? 2.4. Refractive index value is 2.4. C is the correct answer. All right. Is it clear to you, everyone? Okay. Now last question. Question number 71. You can see the light is incident in air on the surface of glass block and it is entering into the denser medium. 50 degree is the angle which the light ray is making with the surface and 25 degree is the angle which this light ray is making with the normal. What is the formula of refractive index? Exactly, students. A is the right answer. Because angle of incidence is this one, which is 90 minus 50, which will be 40. And angle of refraction is 25 degree. Okay. So A is the correct answer. Any confusion here, students, in the topic of refraction? Okay. Now, students, we will start the topic total internal reflection. Total internal reflection is basically one of the application of refraction. I'm repeating with a total internal reflection is the application of refraction. All right. And total internal reflection only occur in denser medium. Okay, students, I am repeating beta. Total internal reflection only occurs in denser medium. All right. To understand the total internal reflection, I want to show you one video. That video is very interesting. Okay. This phenomena will explain the total internal reflection, students, in this video, and we will analyze the critical angle as well. Okay, so now you can see what apparatus we are required to, what apparatus we are required to perform this experiment. This is ray box. The students, first we will set one paper on this board and we will mark the angle before placing the ray box. You can see this is a transparent semicircular glass block. This is a transparent semicircular glass block and we have already marked angle on each side of these glass blocks. This is the ray box which is emitting the light in a narrow beam. Ray box is emitting, the ray box light is moving in a straight line. It is not showing bending. You can see although it is moving in a denser medium, then coming into the air, but it is not showing bending. What is the reason behind this? Why it is not showing bending? Yes, student, light is entering into denser medium, but it is not showing bending. What is the reason? Hafsa is saying it is lining with the normal. Okay. Ray is along the normal. Exactly, beta. When the light ray will move along the normal, it will not show any bending because light is moving along the normal. The angle of incidence is 0 degree. Light never bend along the normal. Okay. So now you can see we have placed the light ray box exactly along the normal. Now we are moving the ray box at the left side of this glass block. So it is showing the phenomena of refraction. Light is entering into air, into denser medium, then it is reflecting. Alright, this is a simple phenomena of refraction. You can see here, students. This is simply refraction because light is coming out in air from denser medium. So now we are continuously increasing the angle. You can see here. So there will be a point at which, देखिए बेटा, this is the incident ray and this is the refracted ray. All right, refracted ray is moving away from the normal. We are continuously increasing the angle. So there will be a point. There will be a point at which this refracted ray will exactly make 90-degree angle with the normal. You can see here, students, this is a point, this is the incident ray, and this one is a refracted ray. So there is a point at which the refracted ray is exactly making 90-degree angle. So this angle of incidence is called critical angle. I am repeating, beta, this angle of incidence is called critical angle because it is a critical situation when the light is incident in the denser medium at an angle when the refracted ray is making 90-degree angle with the normal. This angle of incidence is called critical angle. Are you understanding this thing, students? Okay, so if I will further increase this angle of incidence beyond the critical angle, so now you can see no light, no light is coming outside this glass block. The light is totally internally reflected. All right, light is totally internally reflected. The light moving outside. So this phenomena is defined as total internal reflection. I'm repeating. Assalamu alaikum, Zurez. This phenomena is defined as total internal reflection. Yes, Abdul Rafi, your statement is correct. And you can see, beta, initially when I kept the ray box at 41 degree, so we were getting the refractive ray at 90-degree angle. But when I further increase the angle, which is greater than 41 degrees, so light is internally reflecting. So it means we can achieve total internal reflection only when angle of incidence must be greater than critical angle. Okay, students? We will achieve the total internal reflection only when angle of incidence is greater than critical angle. Are you understanding this question, students? Are you understanding the phenomena of total internal reflection? It will only occur in denser medium. All right. So I'm showing you this video again, beta. Initially, this is the ray box which is passing the light straight towards along the normal. It is a denser medium. All right. Light is moving away from the normal. So it is showing simple refraction. All right. This phenomena is refraction. Incident ray, refracted ray. But when we will continuously increasing the angle, so there will be a point at which this refracted ray will make 90-degree angle. You can see here, it will be a moment only. So this light ray will make exactly 90-degree angle with the normal. So you can see it appears acting on the surface of this semicircular glass block. So this is the 90-degree angle which this refracted ray is making, and this is the incident ray. So this angle of incidence, which is almost 41 degree, you can see it is critical angle. But if I will further increase this angle, so now you can see we have achieved total internal reflection. So no light is escaping outside, all the light is internally reflected. So this is reflection. So the angle of incidence, which is 42 degree, will be equals to angle of reflection, which is also 42 degree. Any confusion here, students? Any confusion here? Are you understanding this phenomena of total internal reflection, beta? Okay, good. Now let's move up towards the presentation. Okay, let me show you the concept here. You can see these are the two different mediums. This medium is water and this medium is air. We have placed the light source in the denser medium. So initially the light is moving straight in a line because it is moving along the normal. In the second diagram, this one, you can see it is simple phenomena of refraction. This is incident ray and this is refracted ray. Alright, this is a simple phenomena of refraction. Now you can observe the third ray, students. This is the incident ray and the refracted ray is exactly making 90-degree angle. So the angle of incidence is called critical angle. This angle of incidence is called critical angle. And if I will further increase the angle of incidence, so light ray will be internally reflected. Okay, and these two angles will be same. Angle I will be equals to angle R because this is the phenomenon of reflection. All right. And now students, and total internal reflection will be only achieved when angle of incidence is greater than critical angle. All right. Okay, so what are the uses of total internal reflection? I can tell you we can observe the phenomena of total internal reflection in many different devices. Like we can see the total internal reflection in optical fiber. Have you ever listened this name, beta, optical fiber? Optical fiber are used for different purpose. Optical fiber are used for different purpose, beta, like it is used to transfer data from one place to another. It is used to transmit electricity. It is used in endoscopy. All right. Mobile data can be also transmitted. All right, students. So basically, optical fiber have many different applications and it works on the principle of total internal reflection. Diamonds. Diamonds sparkle so much because in diamonds, light is internally reflecting many times. Okay, in diamonds, light is internally reflecting many times. So it is also performing the phenomena of total internal reflection. You can see the white light is entering here. It is bending. So this is simple refraction. You can see beta, light should move in a straight line. Light should move in a straight line like this, but it is bending. So this is simple refraction. All right. But when the light will incident on this side, so you can see it is reflecting. It is not coming out. It is reflecting. So this is the simple phenomenon of reflection. Again, it is reflecting here. So it is reflecting multiple times. So that's why diamond sparkle, because the light is internally reflecting many times. Clear, students? All right. Now you can see the different application here. Binoculars. Total internal reflection can be observed in binoculars as well, beta. Okay. You can see these. This is the lens and these are the two prisms, glass prisms. So when the light will enter, the light is it's not escaping outside. You can see it is internally reflecting and it will enter into the human eye. So this phenomena is total internal reflection again. What is the name of this instrument, beta? What is the name of this instrument, students? Nobody is going to tell me. It is periscope. All right, it is periscope. Periscope is an instrument which is used to see those objects which are at certain height. Exactly. Inaya, it is periscope. So periscope also work on the phenomena of total internal reflection. You can see the ray diagram here. All right, this is the internal construction of periscope. These are the two glass prisms which are placed at 45-degree angle. The light ray is incident and it is internally reflecting. This is normal, it is internally reflecting. Again, it is incident at second prism, then it is reflecting in the human eye. So we can see those objects which are at higher altitude clearly with the help of the periscope. So students, you can see beta, total internal reflection phenomena can be observed in many different beta instrument. Now write down this formula beta. This is the formula of refractive index. N is equals to 1 upon sine C. C is the critical angle. If we know the critical angle, so we are able to find the refractive index of any medium. Write down. N is equals to 1 upon sine C. Done? C is the critical angle. If we know the refractive index, so we can calculate the critical angle. All right. Now, students, we will solve some past paper questions. Look at the question number 3. In question number 3, they are saying light passes from air into glass block of refractive index 1.5. Refractive index is given, which is 1.5. Angle of incidence is given 57 degree. We have to calculate angle of refraction and critical angle. So which formula should I use here, students? Should I use two different formulas to calculate two different things? First, we will calculate critical angle. So I told you the formula n is equals to 1 over sine C. So we have to find C, so we will make it independent. So sine C is equals to 1 upon n. So sine C is equals to 1 upon n is basically 1.5. So C is equals to sine inverse 1 divided by 1.5. Well done then. We will use two different formulas. Zurays, are you understanding? Solve this question, solve this beta formula and tell me the value of critical angle. Okay, Zurays, well done. C is equals to sine inverse 1 divided by 1.5. What we are getting? What is the value of critical angle? Hurry up, students, too fast. 41.8 degree. Okay. Inaya is getting 41.8 degree. Other what about other students? Ayan, then Aiza, what you are getting, beta? Answer can be A or answer can be C. Now we have to calculate angle of refraction as well. How we will calculate angle of refraction? Now we will use the second formula. N is equals to sine I over sine R. N is basically 1.5. Sine I is 57 degree. Now we have to calculate sine R. So now students, we will solve, I am solving here. Sine R is equals to sine 57 divided by 1.5. So R is equals to sine inverse